The idea behind this study is to do a quick analysis of a proposed school building. We're thinking that what you could do is create solar studies for specific times of a site in St. Louis, Missouri, and energy studies where what we do is we vary the orientation of the building, which uses mass forms for different activities going on within the building. And then eventually, having seen these movies, you would create and analyze your own building for your own campus, using the same activities that you see in the school building, but using your site. The examples are from standard design text, so there's Newfort's Architects data. See, I've got the quote in the wrong place, but Newfort's Architects data gives areas for activities, like approximately a classroom is 30 feet by 30 feet. And then the other book that I'm referring to is Sun, Wind and Light, that talks about design strategies for or design methodology for looking at getting data about a site. And what we're doing is actually using digital means, whereas a lot of these examples involve hand calculations or making models. I mean making models by hand. So under the Sun studies, what we'll do is we'll create a site from a provided drawing for St. Louis, Missouri, and we'll create shadow studies for specific times. And we'll create animations for both summer and winter solstice. The site looks like this. And in the illustrations, it would look like the shadows are shown falling on the site for different times of the year. What we will do is digitally we'll reproduce those conditions to say, this is for 9 o'clock in the morning, January 21st, this is 9 o'clock, July 21st, and so on. So these are the options that we will recreate so we can understand the shadow pattern on the site. Then we can output a summer solstice study, which is what you see playing at the moment. So we'll be able to see how the shadows change for every 15 minutes of the day. And then same site, but winter solstice, and you can see the play of shadow on the terrain model for that time of year. We'll create a building to analyze where we have multiple options. So the first thing is to do a linear arrangement with optional orientation. So if you think of these, if you look at it, the blue is administration, the reddish is a gymnasium, the green is a classroom, the yellow is the corridor or circulation space. The white I took out eventually in the movies because it was the playground and it wasn't really necessary. But if you think of it as being able to turn that building at intervals of 45 degrees, so it might begin at north-south and then change at 45 degrees. Once you've done that, you could run energy analysis to find out what the consequences of the change in orientation are. So it's like varying one thing and then looking to see what the consequences are. This is the actual example of just showing how you can change to a northeast-southwest or an east-west orientation and change the building. And then subsequent to that, what you would do is you would generate a whole energy study or whole energy analysis. So there'll be 8 options. And then once we've done 8 options, we'll do some other variations on a theme. But energy analysis, tell it it's a school, and it knows where it is. You're located in St. Louis, Missouri, and then off you go to create an energy study. Okay, so the other thing that we'll do is looking at clustering the activities instead of having that linear arrangement, actually having them share more walls by reducing the building footprint a little bit. and maybe stacking activities and then looking to see what that means in terms of the whole energy analysis. The plus of all of this is that when we've created these models, we can use some of the analysis tools. For example, we can use the wind tunnel to look at the site and the reduced wind force behind either the trees or the buildings. So in this first example, what I can do is set the elevation of the study, and you'll see that it actually plays back the wind tunnel data, so you can see in blue the area of reduced wind speed, and you can see what effect it has on the site itself. The other one that will be interesting to us is to do something like a solar radiation study, where we can take any of the options that we have and we can choose the surfaces and then analyze them. So the application for this would be to do something like the location of photovoltaic cells. So if I pick the mass forms that are here, and then it can generate a visual display of how much solar radiation I'm getting on the surface of the model. And it'll show it color-coded, so I can then analyze my building and the consequences of the arrangement that I have. So that's where we're going, and I hope you have fun trying it out.